Let's talk about a cosmic time machine. And, I mean, not the sci-fi kind with all the flashing lights and dials.
Yeah.
I'm talking about the very real, very mind-bending reality of looking into the deep past. We are dialing the clock back 11.5 billion years today.
Mm.
We're looking at a universe that is, well, it's barely out of its infancy, just 2 billion years after the Big Bang.
It's an era astronomers call redshift 4 or 5, a time when the universe is dense, it's hot, and frankly, it's supposed to be a total mess.
Right, the terrible twos of the cosmos. Based on everything we thought we knew, galaxies back then should be these chaotic blobs.
They're regular shapes, yeah, smashing into each other, just these globs of gas trying to figure out how to become stars.
But, and this is where our deep dive today gets really interesting, we are looking at a newly identified galaxy named Cosmos 74706. And this thing is not a blob.
Far from it. It's elegant, it's structured.
It is shaking up the entire field of astronomy because it has a stellar bar. And for anyone listening who follows galaxy morphology, finding a stellar bar at redshift 4 is it's like walking into a kindergarten class and finding a kid filing their taxes, drinking an espresso, and discussing mortgage rates.
Yeah.
It just shouldn't be there yet.
That's a vivid image, but the analogy really holds up. A stellar bar implies a level of dynamical maturity, a settled state that really challenges our standard timeline for how quickly the universe got organized.
So today we are going to unpack this discovery. We've got a heavy stack of sources, a report from the University of Pittsburgh, findings from the American Astronomical Society, and of course the raw data coming out of the James Webb Space Telescope. But we are not stopping at the galaxy.
No, we are not, because we also found a fascinating and highly detached critique in our stack that takes this whole conversation in a wildly different direction.
It really does.
It doesn't just question the galaxy, it challenges the fundamental physics we use to describe it.
I cannot wait to get to that part. We are going to pivot from hard astrophysics to a full-blown philosophical debate about the nature of space itself. We're talking topological vortex theory.
It's going to be a journey from the edge of the visible universe right down to the very definition of a particle.
But let's start with the hard data. Cosmos 74706. This comes from research led by Daniel Ivanov from the University of Pittsburgh. Now, I was looking at the methodology here, and what struck me is that they aren't just looking at some smudge of light. They used the JWFT's NIR cam, the near-infrared camera.
Which is absolutely crucial. You have to remember, at this distance, the expansion of the universe has stretched the light from this galaxy so much.
Right.
What was once visible light is now deep in the infrared. Hubble couldn't see these details because it couldn't really peer through the dust or capture those wavelengths as effectively. JWST just strips all that away.
It shows us the stellar structure underneath.
Exactly. So we aren't seeing the bright, flashy young stars that usually distract us.
We're seeing the old bones of the galaxy.
Correct. And that's what makes the discovery of the bar so significant. When Ivanov's team processed the images, they saw a distinct spiral galaxy, but right through the center. This bright linear feature, a stellar bar.
Okay, let's dig into the mechanics of that.
Yeah.
I think a lot of people hear stellar bar, and they picture, a solid rod, a spoke in a wheel. But that's not what's happening physically, is it?
Not at all. It's not a solid object. Think of it more like a density wave. It's a traffic jam of stars and gas that rotates together as a single unit. But the key is what it does. It's a piece of galactic machinery.
It's an angular momentum killer.
Spot on. That is the physics term for it, yes.
I want to spend a minute on this because it's why this galaxy is so weird. Gas in a galaxy is spinning, right? It has angular momentum. It wants to stay in orbit.
It does. It doesn't want to fall into the center.
So if you want gas to fall into the supermassive black hole at the core or to form a dense central bulge, you have to rob that gas of its energy. You have to slow it down.
And that's exactly what the bar does.
It's like a torque wrench.
It creates a gravitational torque that drags on the gas, causing it to lose that angular momentum. The gas then funnels inward right along the bar.
Like a conveyor belt.
Exactly, a conveyor belt feeding the galactic center.
So it's shoveling coal into the furnace.
Yeah.
But here's the double-edged sword, and this is what I found fascinating in the Pitt report. By funneling all that gas to the center, the bar effectively starves the rest of the galaxy.
It does, doesn't it? That's the phenomenon we call quenching.
Quenching.
By moving the raw material for new stars away from the disk and just dumping it into the core. The bar shuts down star formation in the main body of the galaxy.
So the bar is basically a sign of galactic middle age.
Mm-hmm.
It signals that the wild star-forming youth is over and the galaxy is settling down.
Maturing is the term astronomers prefer, but yes, that's the idea. It means the galaxy has transitioned from chaotic accretion, where it's just pulling in gas from everywhere, to what we call secular evolution, changes happening from the inside out.
And that is why seeing this at redshift 4 is just mind-blowing. This is supposed to be the era of chaos.
Pure chaos. Mergers. Collisions.
Mess. But Cosmos 7470E6 has already built this complex internal machine to regulate its own growth, just 2 billion years after the Big Bang.
It implies that the universe didn't just stumble around in the dark for billions of years. It got its act together incredibly fast.
Oh, okay. I have to play devil's advocate here because I know our listeners are skeptical people.
Right.
We hear about record-breaking discoveries all the time that turn out to be, instrument errors or something. How do we know this isn't just a trick of the light?
And that is a great question. That's the gravitational lensing problem. A lot of previous claims of very early high redshift structures relied on lensing.
Or a massive galaxy cluster in front acts like a magnifying glass.
Right, but a distorted magnifying glass, like a funhouse mirror.
Yeah.
Lensing stretches and distorts light, so critics could always say, that's not a bar, that's just a stretched out blob.
But Ivanov's team didn't use lensing for this, did they?
No, that's the key. Cosmos 74706 is unlensed. We are looking at it directly. And they backed it all up with spectroscopy to confirm the redshift, the distance, precisely.
So there's very little wiggle room here.
Very little. The structure is real.
This puts a lot of pressure on the simulation guys then, because I know the standard cosmological simulations like TNG50, they really struggle to produce bars this early.
They do. In the standard cold dark matter model, the early universe is just dominated by these dark matter halos merging violently. That turbulence usually prevents delicate structures like bars from even forming, let alone surviving.
So finding a real one means the simulations might be missing something.
Exactly. Maybe some physics about how gas cools or how dark matter settles down. It constrains the timeline. It tells us, hey, nature can build complex machinery really, really fast.
And that's the beauty of science, right? Observation leads theory. The universe doesn't care what our computer models say it should do.
It just is.
It just is. That is a perfect segue, because usually this is where we'd stop. We'd say, wow, cool galaxy, science is amazing, and we'd sign off.
But not today.
Not today.
Yeah.
Because in our research stack, we found a response to this kind of discovery that frames the whole thing completely differently. It argues that we're projecting our own biases onto the data.
That we see a galaxy governed by gravity and dark matter because that's the tool set we were taught to use.
But what if the whole tool set is wrong? We're introducing a critique from a source named Baohua Z. HHAAA. And look, this is not your typical internet comment. This is a dense, highly philosophical argument for something called topological vortex theory, or TVT.
And fair warning to everyone listening, this requires a major shift in gears. We are moving from mainstream astrophysics to a radical alternative view of reality.
We really are.
The source material is incredibly critical of what it calls so-called peer-reviewed publications, Nature Science, PNAS. It accuses them of promoting counterintuitive science or even pseudoscience.
It's a heavy charge. But we have to look at the argument underneath the rhetoric, because it is fascinating. The core of this view is that space isn't just an empty void, and it's not a bendable rubber sheet like Einstein described.
Right. The central premise of this TVT is that space is a uniformly incompressible physical entity.
An incompressible fluid, like an ocean that fills the entire universe.
Exactly, an ideal fluid. And according to this theory, everything we see, matter, stars, galaxies, they are not things floating in space. They are space-time vortices of space.
So a galaxy isn't an object, it's a whirlpool.
Precisely. The theory describes matter as defects, or topological phase transitions in this fluid. And what I find most compelling about this source is how it attacks mainstream physics for being too abstract.
Yeah?
It argues that modern science has abandoned, quote, mechanical reality for mathematical tricks.
Okay, we have to talk about the apple analogy, because the source uses this to dismantle particle physics, and it's actually a really clear way to understand the grievance.
It is. It brings up the theta tau puzzle from the 1950s. This was a real crisis in physics.
Let's roleplay this, because it helps. I'll be the old farmer, representing, common sense. You be the modern physicist.
Okay, deal.
Right. So I'm the farmer. I go to the market. I buy 2 boxes of apples. They look the same. They weigh the same. But when I get home, I open box A, and 2 apples roll out. I open box B, 3 apples roll out.
Okay. And in physics terms, these are the theta and tau particles. They looked identical, same mass, same spin, same lifetime, but they decayed into a different number of pions, 2 versus 3.
So as the farmer, I look at you and I say, clearly, these are 2 different kinds of boxes. One is a 2-apple box, and one is a 3-apple box.
And I, the physicist, say, no, they are actually the same box. It's just that the fundamental laws of symmetry, specifically parity, were violated when you open the second one.
And I look at you like you're insane. I say, you're just making up a magic rule to avoid admitting they are different boxes.
And that is exactly the argument that Baohua Zhang is making. The source argues that mainstream science invented parity violation, this idea that the universe behaves differently in a mirror, just to save their tidy classification system.
The source calls it a dirty and ugly operation.
It does, and it argues that if you accept space as a fluid, as TVT suggests, then you don't need these magic mirror-breaking rules, you just need fluid dynamics.
This connects the cobalt-60 example too, right?
Yeah.
The famous Wu experiment that proved parity violation.
Yes. They took cobalt-60 atoms and spun them. They found that electrons preferred to fly out of one end, not the other. It wasn't symmetrical. So mainstream physics says, okay, the universe has a handedness. Left and right are fundamentally different.
But what does the TVT source say?
It says, of course they're different. If these atoms are vortices in a fluid, a vortex spinning clockwise is mechanically different from one spinning counterclockwise.
Like a fan.
Exactly. Think about a fan pushing air. If you spin it backwards, the airflow changes. It's not some mysterious violation of symmetry, it's just mechanics.
And that's the crux of it. The source claims that by treating space as empty, physics has lost the ability to see the mechanism. They're stuck with abstract math probability, violations, dark matter, when they should be looking at flow patterns.
It's a clash between descriptive math and mechanical models. Mainstream science is okay with the math describing the outcome, even if it feels counterintuitive. This topological vortex theory demands a gear and lever explanation for everything.
So let's bring this all the way back to our galaxy, Cosmos 74706.
Okay, so mainstream astronomy looks at that JWST image and says, we see a stellar bar formed by gravitational instability in a cold dark matter halo.
And the TVT perspective would look at that same image and say what?
You are looking at a large-scale vortex in the ocean of space. The bar isn't a structure held up by gravity and orbits, it's the eye of the storm. It's a flow channel where the fluid of space itself is spiraling inward.
And those philosophical questions the source raised suddenly make sense in that context. It asks, does this galaxy come from God, or does it come from the dynamic evolution of space itself?
It's highlighting that if space is a physical substance, then the galaxy is just a transient shape within it, like a ripple in a pond. It didn't have to be created separately. It just emerged from the properties of the fluid.
It really forces you to check your assumptions. We look at that JWST image and we feel so confident. We say, we know what that is, but do we?
We interpret the data through the lens of the theory we currently hold. And while the standard model is incredibly successful, it gave us GPS, nuclear power, it predicted the Higgs boson, it still requires us to believe in things we can't see, like dark matter and dark energy, just to make the cosmic numbers work.
Which, to a skeptic, looks a lot like that parity violation trick again. Oh, the galaxy isn't spinning right. Must be invisible matter.
Exactly. And while we aren't here to say TVT is correct, it is certainly way outside the consensus, it serves as a really valuable check. It reminds us that peer review doesn't mean eternal truth. It just means our best current explanation.
Science is an iterative process. Today's anomaly, like an ancient stellar bar, is that grain of sand that irritates the oyster. Maybe it just forces us to tweak our timeline of galaxy formation. Or maybe, just maybe, it's a clue that the whole ocean is different than we thought.
And that brings us right back to the time machine. We're looking back 11.5 billion years. We are trying to deduce the laws of reality from a few photons of infrared light hitting a gold-plated mirror a million miles from Earth.
It's remarkably impressive that we can deduce anything at all.
It is, but it's also humbling. Whether you see a gravitational system or a fluid vortex, you are looking at something massive, ancient, and completely indifferent to our definitions.
So let's synthesize this for everyone. We have a hard scientific breakthrough. Cosmos 74706.
A galaxy that grew up way too fast. A structure that proves the early universe was capable of rapid, complex organization.
And we have the mechanics of the stellar bar, this cosmic brake system that shuttles gas and quenches star formation.
Which shows us that galaxies have a life cycle. a metabolism that kicks in much, much earlier than we expected.
And hanging over all of this, we have this reminder that our fundamental understanding of space and matter is still very much open for debate.
This source on TVT challenges us to look for the mechanism, not just the math. To ask if we are ignoring the physical reality of space because our equations happen to work well enough without it.
So here is the final thought I want to plant in your brain today. I want you to go look up the image of Cosmos 74706. It's a beautiful little spiral with a slash right through the middle.
It really is a striking image.
When you look at it, I want you to try and see it both ways. First, see it as the astronomer sees it. A massive collection of stars bound by gravity, aging gracefully in an expanding void.
But then, try the alternative.
Yeah, blur your eyes a little. Imagine that the blackness around it isn't empty. Imagine it's a deep, dark ocean. And that galaxy isn't a thing floating in it. It's a whirlpool of it, a place where the ocean of space has twisted itself into a knot.
And if that's true, then we aren't just observers on a rock. We are part of the current.
If space flows, then are we and the Earth and the Milky Way just drifting debris? Or are we part of some massive invisible circulation that we haven't even learned to measure yet? Is the galaxy we see just a whirlpool in an ocean we haven't even learned to see?
It's a thought that makes the universe feel a lot more tangible and a lot more mysterious.
We'll leave you with that vertigo. Thanks for diving in with us today.
Keep looking up.
And keep questioning what you see. Catch you on the next deep dive.